In this video, we're going to go over a technique called factoring by grouping. This is a technique that is often taught in an Algebra 2 class, so if you're watching this as part of Algebra 2, that's great, but sometimes, every once in a while, an Algebra 1 teacher will throw this one in there. What is factoring grouping good for? Well, it's very specific, and it's not always able to be used, but we can use it whenever you have a function that has 4 terms, right? It's great for when you have 4 terms. You can use it for more terms than that, but typically in math, you're going to have 4 terms, and you group the first 2 higher degree terms and the lowest 2 degree terms, and when you take out the GCF from this group and from that group, you'll have a common factor remaining. That's when you know you can factor by grouping. So oftentimes it's something where you have cubic function, then quadratic, linear, and then constant going down like that. So let me show you without any further ado how to do it. So you group things into the highest 2 degrees and lowest 2 degrees. And then if each of those has a GCF, you pull out the GCF. So the GCF of 4n to the third minus 12n squared is 4n to the second. So 4n to the second times, and now what's left in here? Well, you'd have an n, because n times 4n squared gives you 4n cubed, minus 3, because 3 times 4n squared gives you minus 12n squared, with the minus there. Okay, now we have plus, and what's the GCF of 5n minus 15? 5. So we factor out the 5, and you get n minus 3. 5 times n, 5 times minus 3. Now what we notice here is we have a common factor. The n minus 3 has essentially been distributed to 4n squared plus 5. It's in both of them. So we factor out the n minus 3. So we have n minus 3. It's been multiplied by 4n squared and 5. And that is our factored answer. Imagine in this step that an action has taken place in the past, that we distributed n minus 3 to both 4n squared and 5 over to there. And that's how we're going backwards. That's factoring by grouping. It's a neat way to go if you end up with a common factor. If this ended up being like n plus 4 and that was n minus 3, that would tell us that we couldn't factor it by grouping. 4 terms, oftentimes going to be cubic, quadratic, linear, and then constant. Okay, we'll do one more and then a later video where you have to factor out a GCF first. Okay, so first I take my groups of highest powers here. It's set up in a way where you've got 4 terms, 3rd degree, 2nd degree, 1st degree, 0th degree. So it's perfect to try. I'll factor out the GCF of the first 2 terms. It's n squared times n would get me n cubed plus 1 would get me back to n squared. Then the GCF here, I'm going to factor out a negative 2. The reason being is I have 2 minus signs and I have a plus 1 here, so I notice I'd have a plus if I factored out the negative. So that'll leave me with n times negative 2 is negative 2n plus 1, because negative 2 times 1 is negative 2. Now I've got the common factor of n plus 1. That's been distributed. So I factor out n plus 1. I know it's weird factoring out 2 terms, but that is a common parentheses amount. And then what you're left with is n squared minus 2. We've taken the n plus 1, distributed to n squared, distributed to negative 2. If you FOIL this out, or this out, you will end up back at your original starting point, which means you did it right. Factoring by grouping, guys, it's super, super sweet, but very specific when it's needed and usable.